Hello everyone, we are from Group 4 and now we are going to present one of the material in database management. In chapter 5, the material is physical database design and performance. Our group itself consists of Muhammad Farilino Alenri, Hidayatul Rahman Arza, Faisal Muhammad Iqbal, Nur Rahmadani Hernirat, Taufan Perkasa Putra, and Fadilatul Hidayati. And we are going to present this material through learning objective. First, concisely define each of the following key terms. Second, describe the physical database design process, its objective, and its deliverables. 3. Choose storage formats for attributes from a logical data model. 4. Select an appropriate file organization by balancing various important design factors. 5. Describe 3 important types of file organization. 6. Describe the purpose of indexes and the important consideration in selecting attributes to be indexed. And 7. Translate a relational data model into efficient database structures, including knowing when and how to denormalize the logical data model.
Hello everyone, my name is Nur Rahmadani Hernirat. I want to explain.
First, learning objective consists define each of the following key terms. The first term is field, the smallest unit of application data recognized by system software. Next, data type, a data coding scheme recognized by system software, such as a DBMS for representing organizational data. Then, the normalization, the process of transforming normalized relation into non-normalized physical record specification. Next, horizontal partitioning, distribution of the row of the logical relation into several separate tables. Next, vertical partitioning, distribution of columns of the logical relation into several separate physical tables. Then, physical file, a named portion of secondary memory allocated for the purpose of storing physical records. Next term is table space, a non-logical storage unit in which data from one or more database table, view, or other database object may be stored. Next, extend, a contiguous section of this storage space. Then, file organization, a technique for physically arranging the records of file on secondary storage devices. Next, sequential file organization, the storage of records in file in sequence according to primary key value. Next, index file organization, the storage of records either sequentially or non-sequentially with an index that allows software to locate individual records. Then, index, a table or other data structure used to determine in a file the location of records that satisfy some condition. Next term is secondary key, one field or a combination of fields for which more than one records may have the same combination of values. Next, join index, an index on columns from two or more tables that come from the same domain of values. Then, hashed file organization, a storage system in which the address for each record is determined using a hashing algorithm. Next, hashing algorithm, a routine that converts a primary key value into relative records number or relative file address. Then, pointer, a field of data indicating a target address that can be used to locate a related field or records of data. And the last, hash index table, a file organization that uses hashing to map a key into a location in an index where there is a pointer to the actual data records matching the hash key. The second learning objective is describe the physical database design process, its objective and its deliverables. The objective of designing physical file is data processing efficiency. Designing physical files and database requires certain information that should have been collected and produced during prior system development phases. The information needed for physical file and database design includes these requirements. 1. Normalized relation, including estimate for the range of the number of rows in each table. 2. Definition of each attribute, along with physical specification, such as maximum possible length. 3. Description of where and when data are used in various ways. Enter, retrieve, deleted, and update, including typical frequencies of this event. 4. Expectation or requirements for response time and data security, backup, recovery, retention, and integrity. Last, description of the technologies database management system used for implementing the database. Key decisions of the physical database design are A. Choosing the storage format for each attribute from the logical data model. The format and associated parameters are chosen to maximize data integrity and to minimize storage space. B. Giving the database management system guidance regarding how to group attributes from the logical data model into physical records. C. Given the database management system guidance regarding how to arrange similarly structured records in secondary memory using structure so that individual and groups of records can be stored, retrieved, and updated rapidly. Consideration must also be given to protecting data and recovering data if errors are found. D. Selecting structure for storing and connecting files to make retrieving related data more efficient. And last, preparing strategies for handling queries against the database that will optimize performance and take advantage of the file organization and indexes that you will have specified.
My name is Faisal Muhammad Iqbal, and now I'm going to present the learning objective 3, that is choose storage formats or call data type for attributes from a logical data model. The format itself is chosen to minimize storage space and maximize data integrity. Data type is a detailed coding scheme recognized by system software, such as a DBMS, for representing organizational data. Selecting a data type involves you for objectives that will have different relative importance for different applications. 1. Represent all possible values. 2. Improve data integrity. 3. Support all data manipulations. 4. Minimize storage space. An optimal data type for a field can represent every possible value while eliminating illegal values for the associated attribute and can support the required data manipulation.
I am Fadil Atleidayati. I will present Learning Objective 4. Select an appropriate file organization by balancing various important design factors. Okay, before I explain about file organization, first we have to know what is file. File is named collection of related information that is recorded on secondary storage, such as magnetic disk, magnetic table, and optical disk. File organization is technique for physically arranging the record of a file on secondary storage device. With modern relational database management system or DBMS, you don't have to design file organization, but you may be allowed to select an organization and its parameters for table or physical file. This method defines how file records are mapped onto these blocks. File organization is used to describe the way in which the records are stored in terms of the blocks, and the blocks are placed on the storage medium or secondary storage device. In choosing file organization for particular file in database, you should consider 7 important factors. First is fast data retrieval, second is high throughput for processing data input and maintenance transactions. Third is efficient use of storage space. Fourth is protection from failures or data loss. 5th is minimizing need for reorganization. 6th is accommodating growth. And the last one is security from unauthorized use. Often these objectives are in conflict, and you must select a file organization that provides reasonable balance among the criteria within the sources available.
Okay, thank you. Next is about types of file organization, and that will be explained by me. My name is Muhammad Farelino Alandri. There are 5 types of file organization. The first one is heap file organization. The second one is sequential file organization. The third one is index sequential access method file organization, or known as ISAM. The fourth one is hash file organization. And the fifth one is cluster file organization. The first one is heap file organization. In a heap file organization, it is the simplest and the most basic type of organization. The records in the file are not stored in any particular order. Heap file organization works with data blocks. In this method, records are inserted at the end of the file into the data block. No sorting or ordering is required in this method. If a data block is full, the new record is stored in some other block. Here, the other data block need not be the very next data block, but it can be any block in the memory. In this, it is the responsibility of DBMS to store and manage the new record. The pros is, the first one is, it is very good method of file organization for bulk insertion. If there is a large number of data which needs to load into the database at a time, then this method is best suited. The second pros is, in case of small database, fetching and retrieving of record is faster than the sequential record. Next, the cons. The first one is, this method is inefficient for the larger database because it takes time to search or modify the record. And this method is inefficient for large database. This is the example of heap file organization. The second one is sequential file organization. In a sequential file organization, the records in the file are stored in sequence according to a primary key value. To locate a particular record, a program must normally scan the file from the beginning until the desired record is located. This method is the easiest method for the file organization. In this method, files are stored sequentially. This method can be implemented in 2 ways. The first one is pile file method. It is a quite simple method. In this method, we store the record in a sequence, in example, one after another. Here, the record will be inserted in the order in which they are inserted into tables. In case of updating or deleting of any record, the record will be searched in the memory block. When it is found, then it will be marked for deleting and the new record is inserted. The second way is sorted file method. In this method, the new record is always inserted at the file's end, and then it will sort the sequence in ascending or descending order. Sorting of record is based on any primary key or any other key. In the case of modification of any record, it will update the record and then sort the file, and lastly, the update record is placed in the right place. Next is the pros and the cons of sequential file organization. For the pros, the first one is, it contains a fast and efficient method for the huge amount of data. Second one is, in this method, files can be easily stored in cheaper storage mechanism like magnetic tapes. The third one is, it is simple in design. It is required no much effort to store the data. Fourth one is, this method is used when most of the record have to be accessed with grade calculation of a student generating the salary slip and etc. The fifth one is, in this method is used for report generation or statistical calculation. For the cons, the first one is it will waste time as we cannot jump on a particular record that is required, but we have to move sequentially, which takes out time. Second one is sorted file method takes more time and space for sorting the record. Next is index sequential access method file organization, or known as ISAM. ISAM method is an advanced sequential file organization. In this method, records are stored in the file using the primary key. An index value is generated for each primary key and mapped with the record. This index contains the address of the record in the file. If any record has to be retrieved based on its index value, then the address of the data block is fetched and the record are retrieved from the memory. Next are the pros and cons of ISAM. For the pros, the first one is in this method, each record has the address of its data block. Searching a record in a huge database is quick and easy. Second one is this method supports range retrieval and partial retrieval of records. Since the index is based on the primary key values, we can retrieve the data for the given range of value. In the same way, the partial value can also be easily searched. In example, the student name starting with GA can be easily searched. For the cons, the first one is this method requires extra space in the disk to store the index value. The second one is when the new records are inserted, then these files have to be reconstructed to maintain the sequence. Lastly, when the record is deleted, then the space used by it needs to be released. Otherwise, the performance of the data will be slowed down. Next is hash file organization. Hash file organization uses the computation of hash function on some field of the record. The hash function's output determines the location of this block where the records are to be placed. When a record has to be received using the hash key volumes, then the address is generated and the whole record is retrieved using that address. In the same way, when a new record has to be inserted, then the address is generated using the hash key and record is directly inserted. The same process is implied in the case of deleting and updating. In this method, there is no effort for searching and sorting the entire file. In this method, each record will be stored randomly in the memory. Okay, next is pros and cons of hash file organization. For the pros, the first one is records need not be sorted after any of the transaction. Hence, the effort of sorting is reduced in this method. Second one is since block address is known by hash function, accessing any record is very fast. Similarly, updating or deleting a record is also very quick. The third one is this method can handle multiple transactions as each record is independent of other. An example, since there is no dependency on storage location for each record, multiple records can be accessed at the same time. The fourth one is it is suitable for online transaction system like online banking, ticket booking system, and etc. Next is cons. The first one is these methods may accidentally delete the data. For example, in a student table, when hash field is on the std_name column and there are two same names, example name is Anthony, then the same address is generated. In such case, older record will be overwritten by the newer, so there will be the data loss. Thus, hash column needs to be selected with utmost care. Also, correct backup and recovery mechanism has to be established. Second one is, since all the records are randomly stored, they are scattered in the memory, hence memory is not efficiently used. The third one is, if we are searching for range of data, then this method is not suitable because each record will be stored at the random address. Hence range search will not give the correct address range, and searching will be inefficient. For example, searching the employees with salaries from 20K to 30K will be not efficient. Next is searching for record with exact name or value will be not efficient. If the student name starting with B, well, when they have the exact name, it will be not efficient. Next is if there is a search on some columns which is not hash column, then the search will not be efficient. This method is efficient only when the search is done and hash column. Otherwise, it will not be able to find the correct address of the data. Next, if there is multiple hash column, say name and phone number of a person, to generate the address, and if we are searching any record using phone or name alone, will not give a correct result. And lastly, if these hash columns are frequently updated, then the data block address is also changed accordingly. Each update will generate a new address. This is also not acceptable. For the last type of file organization, it is cluster file organization. When the two or more records are stored in the same file, it is known as a cluster. This file will have two or more tables in the same data block, and key attributes which are used to map this table together are stored only once. This method reduces the cost of searching for various records in the different file. The cluster file organization is used when there is a frequent need for joining the table with the same condition. This join will give only a few records from both tables. In the given example, we are retrieving the record for only particular department. This method cannot be used to retrieve the record for the entire department. Next, this is the example of the cluster file organization. Actually, there are two types of cluster. The first one is index cluster. In index cluster, records are grouped based on the cluster key and stored together. The above, from the example I show you, the above employee and department relationship is an example of an index cluster. Here, all the records are grouped based on the cluster key, depth underscore ID, and all the records are grouped. The second one is hash cluster. It is similar to the index cluster. In hash cluster, instead of storing the record based on the cluster key, we generate the value of the hash key for the cluster key and store the record with the same hash key value. Next is the pros and cons of cluster file organization. For the pros, the first one is the cluster file organization is used when there is a frequent request for joining the table with same joining condition. It provides the efficient result when there is a one-on-one meeting between the table. For the cons, the first one is this method has the low performance for a very large database. Second one, if there is any change in joining condition, then this method cannot be used. If we change the condition of joining, then the traversing the file takes a lot of time. Last one is this method is not suitable for a table with a one-on-one condition. Next is comparative feature of different types of file organization. For the first factor is storage space. For heap, no waste space. Sequential, no waste space. For index, no waste space for data but extra space for index. For hash, extra space may be needed to allow for addition and deletion of record after the initial set of record is loaded. The second factor is sequential retrieval on primary key. For heap, requires sorting. For sequential, very fast. For index, moderately fast. For hash, impractical unless using a hash index. The third factor is random retrieval on primary key. For heap, impractical. For sequential, impractical. For index, moderately fast. For hash, very fast. The fourth factor is multiple key retrieval. For heap, possible but requires scanning a whole file. Sequential, possible but requiring scanning a whole file. Index, very fast with multiple index. For hash, not possible unless using a hash index. The next factor is deleting record. For heap, can create waste space or requires reorganization. For sequential, it can create waste space or require reorganizing. For index, if space can be dynamically allocated, this is easy but require a maintenance of index. For hash, it's very easy. Next factor is adding new record. For heap, very easy. For sequential, require writing a file. For index, if space can be dynamically allocated, this is easy but require maintenance for index. For hash, it is very easy, but multiple keys with the same address require extra work. For the last factor is updating record. For heap, is usually require rewriting a file. For sequential, usually requiring rewriting a file. For index is easy but requires maintenance of index. For hash, very easy. Okay, thank you. That's all from me. Yeah, thank you.
Okay, my name is Taufan and I want to explain about the purpose of indexes. Before of that, I want to tell you what is indexing. So, indexing is a data structure that stores a specific value for a column in a table. So, the purpose of indexing is to help speed up the process of extracting a query to a database that already contains a large amount of data. In the simple term is, if you have a library and in that library there are various kind of books and at some point you need a database book, of course you will look for it the computer shelf. Shelf is an analogy to index in a database. Okay, next the important consideration in selecting attribute to be indexed. So, most database manipulation requires satisfactory placement of row several conditions. Given the size of 100 terabyte database, search data for without help is looking for the proverbial needle in a haystack, or Indonesia is mencari jarum di tumpukan jerami. So, the important consideration in selecting attribute to be indexed, scan each row in the table looking for the one you want row may be very slow, especially if the table are large. As is often the case in real-world application, using indexes as previously described can greatly speed up this process, and determining the index is important part of the physical database design. As explained in the index section, indexes on file can be created for either primary or secondary key or both. Usually, an index will be created for the primary key of each table. The index itself is a table with a two columns, the key and the address of the record or records that contain the key. Thank you.
L07 When and how to denormalize the logical data model. Denormalization. Denormalization, in simple words, means transforming normalized relation into non-normalized physical record specification. Denormalization is a mechanism that is often used to improve efficient processing of data and quick access to stored data. In general, denormalization may partition a relation into several physical records, may combine attributes from several relations together into one physical record, or may do a combination of both. This non-denormalization approach is combining several logical tables into one physical table to avoid the need to bring related data back together when they are retrieved from the database. Benefits of denormalization is can improve performance or speed, reducing number of table lookups, but also denormalization has its critics. As Finkelstein and Hoberman discussed, denormalization can increase the chance of errors and inconsistencies, and can force the reprogramming of system if business rules change. For example, redundant copies of the same data caused by a violation of second normal form are often not updated into a synchronized way, and if they are, extra programming is required to ensure that all copies of exactly the same business data are updated together. Further, denormalization optimizes certain data processing at the expense of other data processing. So if the frequencies of different processing activities change, the benefit of the denormalization may no longer exist. Denormalization almost always leads to more storage space for raw data and may more space for database overhead. Thus, denormalization should be an explicit act to gain significant processing speed when other physical design actions are not sufficient to achieve processing expectations. Common denormalization opportunities. There are three common denormalization opportunities. The first one is two entities with a one-to-one relationship. Second is a many-to-many relationship or associative entity with non-key attributes. And the third one is reference data. Two entities with a one-to-one relationship. Even if one of the entities is an optional participant, it may be wise to combine these two relations into one record definition if the matching entity exists most of the time, especially if the access frequency between these two entity types is higher. And this is the example of the a possible denormalization situation with two entities with a one-to-one relationship. In this case, one record could be formed with 4 fields from the student and scholarship application normalized relation, or assuming that application ID is no longer needed. A many-to-many relationship with non-key attributes. Rather than join 3 files to extract data from the 2 basic entities in the relationship, it may be feasible to combine attributes from one of the entities into the record representing the many-to-many relationship, thus avoiding one of the join operations. Again, this would be most advantageous if this joining occurs frequently. And this on the slide, this is the example of a possible denormalization with a many-to-many relationship with non-key attributes. And in this case, fields from item and price quote relation might be combined into one record to avoid having to join all 3 tables together. But this may create considerable duplication of data. In the example, the item fields, such as description, would repeat for each price quote. This would necessitate excessive updating if duplicated data changed. Careful analysis of a composite usage map to study access frequencies and the number of occurrences of price quote per associated vendor or item would be essential to understand the consequences of such denormalization. And the last one is reference data. Reference data exists in an entity on the one side of a one-to-many relationship, and this entity participates in no other database relationships. You should seriously consider merging the two entities in this situation into one record definition when there are few instances of the entity on the many side for each entity instance on the one side. On the PowerPoint on the slide is the example of a possible denormalization with reference data. And in that example, Several items have the same storage instruction, and storage instruction relates only to two items. And the storage instruction data could be stored in the item record to create coarse redundancy and potential for extra data maintenance.
Okay, that's all for our group presentation about physical database design and performance. Hope you understand it. Thank you.